Okay, someone else isn't hearing any audio.
I'm Carol, KP4MD.
I'm James, AE6JG.
All right. And then we've got a couple of people online. We've got Steve, W6VDP.
Turn it down a little bit. A little bit. Hello. Yes, this is Steve online, W6VDP.
And then we've got Gary.
This is Gary, KG6, SNX. Just chilling.
Just chilling. You and the dog. All
Yep.
right. Is Jojo online? Okay. We may end up with a treasurers and membership report later. Carol, how about website activity?
Okay, now we have microphone. Very good evening. This is Carol, KP4MD. I'm webmaster, also vice president of the club, and also section manager for the ARRL Sacramento Valley section. And this is a report on the web resources for River City ARCs for August 2023. And just want to remind you that our web page is n6na.org, and we try to keep this updated with all information about our activities, events, and meetings. And thanks also to all who participate in the website design. And a reminder that our nets are Wednesday nights, 8 p.m. We have the 2-meter net on 145.25 megahertz N6NA repeater, which also is accessible through Echolink and also All-Star. At 8:30, we have our 10-meter net on 28.420 megahertz upper sideband. And everyone's welcome to check into that net regardless of your license class. That's a frequency that we can all get on. Also, at 9 p.m., we have our slow scan television net, which continues strong. And we are now in our 12th year, believe it or not, doing this. And that meets on our 441.30 megahertz repeater. And you're welcome to watch or listen along, or you can watch also on our YouTube live channel. And the link for that is on our website, n6na.org. We regularly have check-ins on YouTube live chat from Louisiana and England as well. Yes, we have people from all over the world that watch us while we're practicing sending.
Must be Bristol.
And remember, also the roundtable net is on 40 meters, and that's Saturdays at 3 p.m., 7181 lower sideband, and that's going strong too. It's very popular. It's website activity for August. We had a total of 726 page views during the month of August, and the peak web page views were 60 on August 1st. And the homepage had the most views, 394. Since the program last month was on setting up your own web SDR, we did set up a page for that, and that had the second most number of views. We had 41 views there. The magnetic loop antenna page had 34 views, our nets page had 30 views, and repeater page had 26 views. And most of our views come from web searches. Google is not distinguishing between Google searches and other web searches. So they're all lumped into that one, number 361. And then we had 301 direct hits to our n6na.org URL, and then the rest were referred from social media and other websites. By region, most of the views came from the United States. We had 7 from the United Kingdom, 6 from Germany, 4 from Finland, 3 from Nigeria, 3 from Poland, 3 from Turkey, and smattering from all those other countries that you see there on the map. On social media, we continue growing. The YouTube channel now has 415 subscribers, which is an increase in 1. Every month, we usually get 1 or 2 more subscribers to join us. We had a total of 416 video views during this month. we have 782 followers on our Facebook page, 149 followers on the Twitter page, which I think is now called X, but everybody still calls it Twitter. Discord chat has 35 members. And just a reminder that if you have any need to contact anyone in the leadership of the club, you can send an email to contact@n6na.org, or if you have any questions about the club, we will then direct your mail to the appropriate person and get you an answer. So that's the end of my report. Thank you so much.
Carol, thank you. Job well done as usual. Tonight, you're probably all aware, is our Homebrew night. We've got 4 entrants for this evening's program. But let me touch on a couple of other things that are upcoming. Next month is in October, we always have our White Elephant Sale. Is everyone aware of what that means? You bring your stuff that you wish to donate to the club's benefit, and then we raffle it off here, and people take those products home. So it's a way for us to make a couple of bucks, and it's a way for you to clean out the garage. It works that way. It's going to be right here. Jojo, we are going to have a treasurer's report. So a couple other things. In November in December, we have our annual holiday meal, our kind of festive meal. And this year we're holding it at the Spaghetti Factory on Sunrise. That's because the deli is no longer the deli. It's ashes and ashes. So in our October newsletter, we're going to publish the menu choices and how to place your orders. We have to place the orders in advance of the event. It's going to be in the $20 range for your meal and a drink. And we have to turn in those orders so they have them ready for us to go. Now, in case we have one member I'm aware of that needs a special meal, gluten-free, and I spoke with them out there. They can easily accommodate that at the site, so we're covered. The other thing that we should mention tonight is officer. We vote on officers at the November meeting, and if anybody is interested in running for an officer position, just use the contact link on our website and enter your name. We entertain all those who are interested, and frankly, it's kind of a lot of fun. It's the old adage, the more you put in, the more you get out, and it really does work that way. A couple other things we have going on. The board is considering a couple of things. One is we're going to have to revise our bylaws. They're 15 years old, and there's been all kinds of changes in laws relative to equal inclusion, those types of things. And in order for those bylaws to pass, what percentage of our membership has to vote on that? We need a 2/3 majority to pass these revisions. And we need to pass the revisions to be in compliance with the law. So when we send this out, I would expect each of you to vote on it so we can get this thing out of our hair, okay? And one of the other things we're playing with currently is a backup repeater option, should ours happen to go down due to unexpected events. Jennifer, do you want to mention anything about Eris and how that's going? Give you this microphone.
Just a real quick update. We heard today that the streaming plan and our equipment plan was approved finally, so we're good to go on that. And we're going to start in a couple weeks with the classes, bunch of Wednesdays, 7 Wednesdays in a row for the Girl Scouts. Okay, the Eris plan, it's the Girl Scout Club number 1089 is going to be talking to an astronaut on the International Space Station, and the club is helping sponsor that with assistance from various technical people, as well as loaning some equipment. And the Girl Scout troop and maybe some additional members from the local Girl Scouts in the area will be joining the class on Wednesday nights, 7 Wednesday nights, starting a couple of weeks at the Girl Scout Center on Elvis at 6601 Elvis Avenue. And it'll be from 6 to 8 o'clock, maybe a little longer. Once that program, it's a specific program from ARIS, we get done with that, then we go into here's our gear, how to use it. So there's kind of a 2 parts to it. And when it's done, they should get actually 2 badges out of it. 1, the ARRL badge, and 2, a badge for ARIS, for the Girl Scouts. So we're moving along. The next step this week is finalize the agenda and calendar for the training and get everybody's signups that are going to join us there with the Girl Scouts. And then finalize our equipment list and start fundraising for the gear that we don't have. So, yep.
How many clubs?
In this round, which would be the spring round, winter spring round, I think there was 11. So there's 11. We're one of 11, and we're the only Girl Scout troop in spring. And there's usually somewhere between 7 and 12 twice a year that get to do this. And because they just got a new set of astronauts coming up there, I'm hoping that the Girl Scouts will get the most recent addition. And I can't remember her name, the astronaut's name, but there's a new female astronaut, and I hope the Girl Scouts will be able to get that as their contact. I think that'd be really inspiring for them. So that's it for me.
Jennifer, thank you. And again, we're a fairly active club. Not too many ARRL affiliated clubs are involved in this. One other thing, Jojo, do you want to give your treasurer membership report at this point?
Well, good evening, everybody. My name is Jojo, call sign KN6HTD. I'm presenting our club treasurers and membership report for the month of September. And just to give a quick update, all the club members have been onboarded to the HamClubOnline, which I encourage everybody to please log on and experience how the new platform feels like, because you can see everybody else in that platform, all the other members. If you are a member of Sierra Foothills, you'll see yourself in 2 clubs because they share the same platform. At any rate, we have a total of 148. I just updated the n6na.org website. It says 148. I think I have 147 in HamClubOnline. I have yet to find the discrepancy. But rest assured, we're up to date with our membership, and I will encourage you to log in yourself because some have not really logged into the HamClubOnline yet, and I cannot change some of the emails there. Yes, that's one of the advantages with HamClubOnline. If you renew today, for example, September 5, it'll be good for the next 365 days, which means you won't be up for renewal until September of 2024. So it doesn't matter which day or time of the year you renew, you get 365 worth of your membership. So it's not the usual January to December of every year. Actually, HamClubOnline monitors the last date of your membership. So it doesn't start your new payment until the current period ends. It's saved up. Yes, yes. You get a credit of $20, as you can see.
I hear you. So Yeah, just have to repeat what people say if they don't have a microphone, Jojo.
I think this is the the end of membership. We have 9,724.17 in our account, and it's comprised of 3,466 for the repeater fund and general fund of 6,257. Can somebody pull up HamClubOnline or somebody who has logged in? Can you log in? Yes, because I see it differently. I see everything. I want to show members how the experience looks like when you're a member. But it shouldn't be hard. You have to register for email and password.
Jojo, thank you. This HamClubOnline thing is going to be extremely helpful. Yes, Murray? You're in.
If you sign into this website and you are a life member, and it asks the question, if you want to pay a membership fee, what happens then?
Our HamClubOnline platform has several membership categories, and one of those is the lifetime membership. It won't ask you for any membership fee, and you're part of the 11 members who are not supposed to pay anything. So,
But if you want to give the money out, I'll take that too. Oh, okay. Well, you know, once you're a capitalist, you're always a capitalist. And I don't know how to explain that. Oh, I got to get back in the picture. Am I in the picture now? So at this point, we're going to have a little introduction about Homebrew by the illustrious Mr. Robert Mix, rocket scientist extraordinaire. And he has a microphone.
That would be me. I hope I'm at the right club to introduce home brewing. The goal of home brewing is to make high-cost, low-quality beer as a step up from Bud Light, which is very low-quality beer. Oh, you're laughing. I must be at the radio club. Oh, all right, okay. Don't drink before building circuits with a soldering iron in your hand. You might drop it in your lap. Yeah, so anyway, the goal of home brewing is to build low-cost, high-quality radios and learn how radios work. Radio electronics is a cheap hobby for a cheap guy like me to build a receiver for $5. It was a very expensive hobby in the middle of the last century when I was a kid in the 1950s. So my agenda is to talk about kits, circuit simulation, oscillators, receivers, and transceivers. And this is just an introduction, so I'm assuming I only have like 20 minutes at the most, and then people have to do their presentations. Kits, it's best to start with a kit because a kit comes with all parts and full instructions. Unless, I have to warn you, if it's a Chinese kit, the instructions will all be in Chinese. So that makes it even more challenging, but they usually give you a circuit diagram, which is a visual international language. So I have built things, Chinese kits, and here is an example of one. Works great at my house, but not here. Okay. It's an AM radio. AM radio that costs $5. You can still buy an AM FM radio for $5 from China. I don't know anything about the shipping. When I bought it, the shipping was free because the US government was subsidizing postage from China. Now I think you have to pay some shipping, but you can still get the basic kit for $5. and that's a great way to get going. And now what I want to do is get back to my desktop. So I share the screen, and I don't know how to get out of this. So it's been 6 months or something since I did do that. Well, I didn't set up anything. Oh, here, this is what I want to do. Quick share. Okay. Okay, great. And this Microsoft has updated my computer several times. So what used to be the fastest computer on earth is now slow. So I don't know how fast I can move through this, but I'll try to do this. I believe it's loading. This is an MP4. It's coming up on my computer. I don't know why you don't see it, but how come on my computer doesn't show up there? Well, that's okay. Not really. I want to run it. I want to run it. See, and it's loading now and running, but it's not showing up on the screen. Oh, okay. Wow, this is going to be too clumsy. Share, yeah. All right. A 10-year-old boy in our family, he asked me if I knew anything about Arduinos and Raspberry Pis, and I said yes. And would you like to learn? I'd love to teach you. So I taught a class, and I thought that we ought to work towards having an electric car that follows a track. And I learned all kinds of stuff that I'm not going to talk about. But anyway, this is a $3 kit, Chinese kit that I bought. And I put it together. I actually bought two of them, one for the 10-year-old and one for myself. And I put this together to make sure it works before I'm trying to get him to do it. Anyway, it's going on my laptop, but very slow up there. But anyway, so what you do, this is a line following electric car, and you make a black track for it to follow. This one's a printed one that it's on right now, but right next to it is one that I made with electrical tape. And it works on both of them, but this other, the one that's smooth works a lot better on it. So anyway. Very slow to translate over there. It's going around and around on my computer, but not on the screen here. Huh. Okay, now I have to stop sharing this and go to something else, I guess. Yeah. Yeah. Anyway, whether you're building radios or robots, you're going to use the same electronic components. So from left to right, we've got resistors, capacitors, an inductor, and transistors. And almost all the circuitry uses these components. So it ain't that tough, you know? Very few things you have to learn, you know? Anyway, and down at the bottom here, is a breadboard, what we call a breadboard. I want to see if I can actually move on from here. Yeah. Okay, cool. So here's a breadboard with those parts, 25 cents worth of parts plugged into this breadboard. The breadboard has a channel, a gap down the middle of it that divides the breadboard into two separate breadboards, basically. So from the gap up is one breadboard, from the gap down is another one. At the bottom here, we have an oscillator, a twin T oscillator that produces an audio signal. Parts are plugged in there, and all we have to do is supply power at the bottom of the bottom half here. The blue is for negative and the pink is for positive, and then that circuit will operate. If we move the power up to the top half of it, then the top circuit will operate. The breadboard sells for like 99 cents, so that's another 99 cents past the 25 cents for the components. Yeah. Right. Okay, yeah. And now I need to move to something else. Yummy. This is a little memory prompt here that I've got. Okay. That twin T oscillator that was on the bottom of the breadboard, this is the circuit diagram for it in the picture here. And I am going to run this. It will run software known as LT Spice, which Spice is short for simulation program with integrated circuit emphasis. And the LT part is from Linear Technology, the company that supplied this software. And I guess now I have to get out here again, move on to what I'm looking at. Oh, it's not what I wanted to do. Huh, okay. Oh, I didn't have to do the share. I double click on it. Anyway, okay. So we're inside the simulator for this circuit right now. And I drew this circuit using the symbols that are up here at the top right-hand side. Doesn't really show up very well on the screen there, but anyway. Then there's this little icon up here. That's a little man that's running. And to run the simulation, you click on that. And it should run. Okay. Gave me another window. And then I can move the pointer down to the point where I want to check the circuit, see what's going on in the circuit. So I'm pointing at this point in the circuit, and bingo, this is what I should see if I attached an oscilloscope to that point. So I'm getting an audio signal here, a sine wave. And if you do the math, you can see that it's about 800 hertz, which is good for a CW side tone. CW guys like anywhere between 600 and 800 hertz, they tell me. I'm not a CW guy. I can spell CW, but I can't do it really. Anyway, so that's the audio circuit, and I also have an RF one. So I'll get out of there, God willing. Okay. it up. Now I have to somehow get over there. Too many steps. Double clicking worked last time. I'll do it. Okay. All right. So here's an RF circuit. This is the simplest one I could come up with. And I'm going to run it. Click on the little man up there. It's going to run eventually. And then I can check what the signal looks like at this point in the circuit. And I get another sign. Yeah. I'm not going to talk about it. This is supposed to be an introduction. I need to move fast. Anyway, this is up around the 40 meter band. So it's 6 or 7 megahertz at this point, depending on the values used. So I'm going to get out of that. And guess I want to kill it. Oh. Screen sharing has stopped. Okay. I think I could have done this. I don't know. No, just not. Now I don't know where I am. Yeah. Yeah. Okay. Nope. Okay. Okay. The oscilloscope is just a visual aid. You zoom in on the oscilloscope and you can see that this twin T oscillator is at 789 hertz. About all I wanted to show with that. And I want to move to another one. And I believe, maybe I didn't, but I intended to say that there are like 5 ways to build circuits. We saw the breadboard. And now I'm showing you another way here. This is the same circuit, ugly style we call it, or some people call it the dead bug style. All the parts just soldered together. It's 3-dimensional, you know, in space, instead of in 2-dimensionally on a breadboard. So you can do it that way too. And that also works. And you can see on the oscilloscope, it's working fine there. All right, what's next? This one is the RF circuit. And you can see it's up at 6 megahertz according to the scope here. Okay. But if you can't afford an oscilloscope, you can get a digital multimeter that does frequency. And I was going to spend $400 for a fluke digital multimeter, but it turned out when I checked all the specs and everything, it wouldn't work for this kind of work. But and I bought a Chinese DMM, and that wasn't very good. But the next model in the series was this one, and this one is amazing, $55, and it measures everything, not everything, but frequency on here is up at 5.934 megahertz. So anyway, so that's like the best tool you should buy after what? I don't know, a soldering iron. But I don't know how far down it'll go. It tops out at 10 megahertz. Okay. I'm now loading Open Office slowly. Yeah, okay. Yeah. Anybody have any questions while I'm doing this? I'm not sure I can do two things at once, but. Okay. Next, I'm going to talk about receivers. So here's a block diagram for a receiver. I designed this antenna. I call it a tripole. You don't see it? Oh, that's right. Okay, yeah. I got it. Sorry. Got me, what I have to do here. I guess so. It's not on here, no. Close what? Okay. I minimized, unfortunately, so. I minimized it, yeah. Down here, okay. How do I do the screen share? Can't get down. Oh. This one?
No.
Didn't think so.
Go back to Zoom.
It said screen sharing at the top of that. Okay. This one. Okay, there we go. Now they should see it. Okay. Now this is a block diagram for a receiver. In the upper left is the antenna that I designed. It's called a tripole. There are trillions and trillions of signals from all over the universe coming in. And so we have to filter it out and get down to a small band of frequencies. So those frequencies come into a filter. And then we have an oscillator that we can vary. And that oscillator frequency has to be mixed with the signal coming in from the antenna through the filter. And we get what's called product detection taking place. We'll get an audio signal that we then pass off to an amplifier and amplify. So this is a simple block diagram of a receiver. How to get back to where I was. I think that's it.
Bob, after the receiver, we need to get on with our.
Yeah, I think so. Okay, here are a couple of receivers. This one at the bottom is the tin ear it covers the entire 40-meter band. It's simple to assemble. I think Phil designed the circuit. He also designed this block of plastic up here for the permeability tuned inductor. There's a brass screw that goes in and out and through this coil here to choose the frequency. A kit was offered by the American QRP Club for that, and I think Phil took that manual and he designed the circuit, or the circuit board, the printed circuit board. So that's a second way.
Shameless copycat.
Okay. Plagiarism is a great resource. Yeah. I did the same thing with this other receiver at the top. This one at the top receives WWV at 10 megahertz, which you can see if you look at the at the crystal here. It receives both Fort Collins, Colorado, and Kauai in the Hawaiian Islands. I listen to it every day to see what propagation is doing. This costs about $5, and it's built on another way of building on a strip board, it's called. So now I'm going to move to, this is the backs of the two boards. The printed circuit board that you saw at the bottom before is now at the top. So I flipped it over. And then the strip boards down here at the bottom. You can see why it's called a strip board. There are all these strips going horizontally here. And I'll move faster. This is a wonderful tool, a $60-some tool on the right-hand side. It's called the Tiny SA. The SA stands for Spectrum Analyzer. You can see a spectrum on the display there. It has a little antenna sticking out here. And on the left-hand side is a VFO that I designed, and it's putting out a signal at 7040 kilohertz, and it's going out this clock generator here. In the middle is an Arduino that has software that reads the inputs from this keypad and from an encoder down here, and it outputs to this display and to this clock generator board that sends a signal out. This Tiny SA instrument on the right can be used as a spectrum analyzer or as a signal generator. And I used it as a signal generator when Phil loaned me this receiver that he built from circuit that Pete Giuliano, who spoke to us through Zoom one time, designed. And so this is built in another way, a fifth way of building a circuit. This is called Manhattan style. It is. Is it? Yeah. Okay, I was gonna say that you cut out little copper islands here that you built on. It's both. Okay, it's both. Yeah. It's Phil's both technique. Yeah. Anyway, I when he loaned that to me, I hooked up to this connector here, the Tiny SA as a signal generator, and I was able to tune stations. So Tiny SA is an amazing instrument. And then time went by, I don't know how many months, and I decided, hey, maybe my VFO could plug straight into this circuit, this receiver that Phil built. And sure enough, I plug it in, and doggone, I was listening to single sideband and CW, and a bunch of hams chatting here and there in the noontime net, and all on, so all at the same time. So anyway, the last thing I have here is a Pixie. A Pixie is a transceiver, and there's a person here that's going to talk about his modifications of a Pixie. But I built this Pixie on a strip board too, and it works for receiving and transmitting. Anyway, that's all I have to say. I have a summary, but we'll skip the summary and dive into the rest of the program.
It's a great job, Bob. When I was a young man, that was a long time ago, I used to play with this stuff, and the one thing I wished I always get my hands on was an oscilloscope. Today, you can pick up an oscilloscope for $100. And that LT Spice thing you saw there, it's free. And that software has a signal generator and an oscilloscope and a logic analyzer and every component you can possibly imagine. And you could build a nuclear reactor in LT Spice and go through every system, and it works. The circuits follow the model. So anybody interested in doing home brew, LT Spice is free. You don't need a resistor, a capacitor. All you need is your laptop. And then like the tiny SA, that spectrum analyzer, the cheapest spectrum analyzer you could buy up until about 5 years ago was about $2,000. And if you went back another 5 years, it was 20 grand. And if you went back another 10 years, it was probably 50 grand. So this stuff is so affordable these days. If you have any kind of interest, you can get into it for a song. And one of the reasons we do homebrew night is to kind of encourage you to try, because ham radio, while it is a social event, a social hobby, it's also a technical hobby. And if you don't believe it's a technical hobby, take a cold hard look at the test you had to take to get your license. It's a technical skill, but it's a great social program as well. Now, with that, we've got, I think, 4 participants this evening. 5. We have 5. Okay. Bob's going to be a judge. I'm going to be a judge. Carol's going to be a judge. And we might just as well start with the first one, who is Mr. Hank Thompson. I'm going to give you the microphone, and I'm going to shut up. You know, I used to do that same routine in elementary school. You know, it gets dark at 8 o'clock. It's 7:50. Let's go take a quick look. We're going to put everybody on pause here. Yeah, hang loose.
People on Zoom, please stand by. Everybody's going out to take a look at the motorcycle installation. Sorry, we don't have a portable camera to go out there. Oh, actually, we could. We can log on one of these on a cell phone.
Hey, Carl, can you hear me? I'm just doing an audio check. N6CKV.
Yeah, I can hear you.
Okay, good.
Yeah, so somebody homebrewed a motorcycle, huh?
Well, they did something, Hank did, so,
Cool.
okay. Thanks for the sound check.
No problem.
Just come out there. All right, for those of you on Zoom, my name's Eric Walton, KN6QQT. I have joined the Zoom channel. I happen to be here. I'm gonna go out and see if I can't get this thing on camera so you guys can see it. So if you'll hang tight, I'll be right there.
Thank you.
All right.
It has performed well when we've been on the road. We took the first
I apologize. We're not really getting sound from out in the parking lot.
and see all those pictures. It's your and Gimenes door. So when we pull up front door, anyway, we knew that we were leaving on our trip, and so we walked in part of the restaurant while we were on our way back to stop for lunch. And my phone rang. Are you guys okay? You're not moving. And I said, lunch, George, lunch and gas. And he said, oh, okay. So it has the two aspects. Kind of long way back when you've gone on a trip, but it also they can find it. And somebody's looking there and saying, hey, you know, kind of cool. I think it was really
So this is a 3D printed box. Yeah, may not.
Has anyone ever tried operating a motorcycle with two gears?
Hey, Phil. Phil, ask Ken where he's at.
Ken, where you at?
I'm in Evanston, Wyoming.
Are there any jackalopes around?
No, too dark.
Too dark. Those of you who weren't here and missed out seeing that motorcycle, that was quite a show. Very impressive stuff. Very well done, Hank. Bill? Do we have Bill? Ah, there he is. You're going to show us something about a Pixie.
Hello. Oh, there it is. So I'm Bill, November 6 Whiskey Lima Mike. I was licensed in 2022. So very new ham. So take everything I say with a grain of salt. This is improving the Pixie QRP transceiver. It's a very cheap transceiver, which you'll learn about a little bit in this presentation. I tried my best not to put like, Tinkerbell and fairy dust all in these slides. So you're welcome. All right, go ahead and give the next one. Oh, go ahead. So the objective. So what are we doing here? So we want to learn more about DIY radios, building radios, how they work. To do that, I decided I wanted to modify an existing kit to enhance its functionality, add something to something just to learn a little more about it. Because to modify it, you kind of have to learn how it works. So I want to keep the project really small and on a small budget, and of course have fun. So let's see if we could accomplish those goals. Go ahead. So what is a Pixie? Pixie is a very small radio. It's a little smaller than a Post-it note. So most people have seen a Pixie before. It's a very popular build for ham radio clubs to do because it's very cheap. It's like $3 from AliExpress, $10 if you get it from Amazon. It's QRP, does CW, and it's a direct conversion. Usually it comes with a crystal that's in the extra portion of the band, which is part of the problem for a lot of people. There's not everybody's an extra. So there's all the parts. It's 2 transistors, a couple diodes, nothing really fancy. There's an audio amplifier is probably the most advanced chip on it. It comes in a cool case. So, all right, next slide, please. So let's improve the Pixie. So how are we going to do that? So I have two things I want to do to this Pixie just to make it a little more usable. Like I said before, it comes with a crystal, so it's set on that exact frequency. There's a little pot to be able to change the hertz, change the frequency a little bit by a few hertz, but you're really locked into that crystal. So we want to make it a little more frequency agile. And then there's also really bad AM breakthrough, which Phil did a great presentation on. So we want to try to filter out all that AM noise that's coming in with the Pixie because it is a direct conversion. So there's very little filtering. Go ahead, next slide. So I'm not the first person to try to modify a Pixie. It's a very cheap project. So there's a lot of other people that you might be interested who've done really neat things with this radio. So just a couple just to touch on. People have added side tones because there's no side tone to it. There's people have had single sideband reception, improved the speaker. The really neat one is K6ARK. He actually minified it. So first he made one that was only 2 ounces, which is pretty impressive in that little tiny Altoids tin. And then he made it even smaller, which is 2.7 grams, which is, you could see his hand there. It's all surface mount, very small. And then the keyer is actually that metal bit right there. He just pushes down and it actually keys there. So it's really neat. So that's kind of things you could do with this, just a small little fun project. And they get advanced. So that one's kind of crazy. They just keep building more and more onto it. So next slide. So how does the Pixie work? So there's a really good talk already about how the Pixie works. I'm just going to give you the briefs of what I learned and how we're going to kind of modify this. So that's down here. It's by NCRC. I should search them with Pixie. You'll find this. It's an amazing resource to learn how the Pixie actually works. So that's what I used here. So there's 3 main sections of the Pixie. There's a local oscillator, which actually is the clock section, and that drives the mixer, which is what actually gives you the signal that you want to amplify later. And then there's the auto amplifier where you could listen to those signals. So there's a few magic components in this that if you wanted to modify and try to just enhance your Pixie with very little effort. There's C4, which kind of filters the audio section out of the mixer, because the mixer is the product in the sum, and then the existing, the two existing signals. So that C4 is really magical because it just it puts everything else to ground except for the audio signals, which is kind of cool. So if you mess with that, you might get a different sound. And then R4 is also what helps it actually become a transmitter. So go to the next slide. So what are we going to do? We're going to add a VFO to the Pixie. So I chose the SI5351 because it's a very popular choice for existing homebrew projects to add a VFO. A lot of existing kits use this, so I thought I'd learn more about it. But to use it, you actually have to tell it what to do. So what we're going to use to set the VFO, the SI5351, is this Arduino microchip. You could use your computer, or you could use somebody. I've seen people use other things to interface with it, but I used an Arduino. And then you need a method to interact with Arduino, so a computer or a LCD screen, buttons, so on and so forth. Next slide. So how much does this cost? Very cheap. So there's the parts I bought, more or less. The screen I haven't done yet, but you can see you get all this from AliExpress for, nothing really. It's under $10 with shipping. And then you need a couple capacitors, buttons, things like that. Go next slide. So let's modify the Pixie to accept our VFO, because we want to be able to actually change the frequency and go to different places than just that one crystal that comes with it. So this is what we have to end up doing. The way I figured this out is I stared at it long enough, and I simulated an LT Spice, and I started removing pieces and adding in signals and just trying to figure out where it would make sense to work. So this is what I came up with. I ended up removing the crystal. That's the yellow section there, or the orange, sorry. And then you put a capacitor over it, just to allow the actual signal from the SI5351 to go to Q2, which is the amplifier and mixer portion. So we are going to inject our signal into the green circle there to be able to add our VFO. And next slide. So that's great. We figured out where to put the signal, but how do you do that? Like, what do you have to do? So you have to actually tell the SI5351 what to do. You have to program it. So I'm using Arduino. There's a very simple wiring diagram from Adafruit on how to interface your Arduino with your SI5351. And then here's a block diagram of actually what it is. So the library from Adafruit's a little complicated to use, because first you have to, there's an external local oscillator, which is set to usually 25 megahertz. And then you have to set pill A or pill B, which is those two sections there inside the block diagram. And you can only set them by multiples of any value from 15 to 90. And then you have to divide it down even further to get your frequency. So this is the code to do all that. It's kind of complicated. And I could probably figure out how to do it and write a really fancy thing as I turn the knob to find the exact frequency instead of doing all this math. But I knew there was probably a better way, so I searched a little bit. So go next slide. So it turned out, yeah, of course there's a better way of doing this. So we're going to utilize open source software. There's a QRP guys, they made a really good VFO kit. And that VFO kit, if you notice right here in the red section, that looks kind of like the breakout board for an SI5351. And they give you the source code for this, their VFO. And I thought I would just use it. So I did. Yeah, it's a lot easier. So all that code ended up being just this one line where you write the frequency. This is me interfacing with the Arduino, asking through serial what frequency you would like to set your radio to. And this is how I programmed the local oscillator to be able to change frequencies on my little radio. I'll go next slide. Yeah, I think so. He also has another library. So you didn't have to copy QRP guys. So yeah. And T7S, he also has an open source library to utilize also if you don't want to use QRP guys. And then the other issue then there was two things we wanted to prove. The second thing we wanted to prove was the filtering on the Pixie, because there's a lot of AM broadcasts. As soon as I got this working, I plugged it in, I went to a frequency, and I was all excited to try to hear some CW or something. And all I heard was an AM broadcast station nearby. And then I changed the frequency again, same station. No matter what I did, it came in great, but it's not really what I was after. So I Googled around. Yes, it's a common issue. So I Googled around. I found some calculators on how to make a high pass filter to kind of break through the get rid of the AM signals. So I found this really great one from Whiskey 1 Victor Lima Foxtrot, and I decided to build it. So there's me building it on a small proto board, and I tested it on my Nano VNA over there. You can see that it filters all the signals from 2.1 megahertz down, just it fall off the world. So this is it before actually inserting it in line with my antenna system. And this is me, this is after. So you can see the difference. We're at 1 megahertz here, right where the AM stations kind of start. So it got rid of all the AM stations. I plugged in the Pixie afterwards and it sounded great. I was able to actually hear things. So it was good. I'll go next slide. So the takeaways from this project. So the Pixie is a really low cost way to learn and just kind of play around with radios. I was telling Jen I actually broke the first one and I didn't really care because I had 5 of them on order from AliExpress and I went on to the next one to play around with more things. Even after the modifications, even the modifications I showed you before from like the other folks who are much more skilled than me, it is still a terrible radio. It's not your daily driver. No, there's not. It's 2 transistors at the end of the day. So I wouldn't recommend it. It's really good to learn and to learn with very little risk. So that's a good way to look at the Pixie. Even worse, the Pixie is a direct conversion. So you could, if you're listening to a station, they could potentially hear you listening to them. They'll hear your LO. The local oscillator can break through. So if you have a nearby radio, you'll actually hear the local oscillator. It's pretty loud. So I don't know if that's in compliance. So I used a dummy load for most of my testing. Eventually, I'm going to add a LCD screen and buttons to control this. This was just a really basic test to see if I could even do it. And yeah, if you want to do more than 40 meters, the built-in filtering for the Pixie is only 440. So you're going to have to modify it to do more high pass filters if you wanted to go to like 20 meters or so on. Then always use a DC blocking capacitor with your SI5351 because you'll break it otherwise. Don't ask me how I know. And I still don't know Morse code. So, go next slide. So a practical application. So now I know how to use an SI5351 to build a VFO. This is on my bench right now. This is a Heath kit. It's a DX35. It's a transceiver. It's not a transceiver. It's only a transmitter. And it's supposed to have 3, you could control the frequency with 3 crystals or a VFO. And you notice I don't have any crystals, but I have the VFO. So I think the next practical application of this knowledge is to try to get this on the air with my own VFO. So we'll see. Yeah, and probably amplify it also. It drives the tubes directly. So I think I need a little more power. So I might need to amplify it a little more. So that'll be a fun project. But at least now I know how to build a VFO more or less. Go next slide. So there's the LT Spice simulation I made. It's a little complicated. And then there's me testing things with my messy desk and putting it all together. So thank you. That's everything.
Bill, that was very impressive. You know, first of all, you jumped in with LT Spice, and most people are not quite willing to try LT Spice. So kudos to you. The fact that you drug out a nano and you did a bad pass test on your filter, again, kudos. The SI5351 is the rigor of VFOs in the ham world today. So the use of the Arduino, the SI5351, all of it very, very impressive. And I like your bench. You got stuff scattered everywhere. It's beautiful. You know, a clean desk is the sure sign of a sick mind. Is that right, Bob? Oh. James, you're up.
I did not build a radio. I did do a little bit of wiring, power pole connectors. One of the things that I've noticed in this hobby is that we sit a lot, probably too much. And so, next slide, please. This is my shack. I did not take anything apart. Actually, I did. I had to put jumpers into the signaling, so I had to open that up and make it work for the ASU. And I coiled the cables really well. I kept power all on one side, very neat. And, you know, the grounding bus and everything on the other side. So what you see here is my shack. Next slide, please. And what you see here is what it looks like when I'm sitting on the left and what it looks like when I'm standing on the right. Obviously, pull the chair away. And so what I have found, again, in this hobby is that we sit way too much. The other thing I use a lot is the crossband repeat on the FTM 400. When I'm walking the dog, I'll be on nets, but I'll use the crossband repeat. So I walk and I stand as much as possible. All right, next slide. This is just a different angle so you can see it from the side. So you can see on the left where it's low, and you can see on the right where it's up. So the trick, of course, is to wire it up so the cables don't get caught when it moves up and down, and try to keep it as neat as possible. Okay, next slide, please. The other thing I have in my shack is a power supply and automatic battery backup. So your very common PowerWorks 30 amp power supply goes into a bus here and then into an Epic power gate and a lithium battery. And so when the power, I often actually run just on battery only, but if there's a power outage or sometimes I'll just switch off the power, it automatically switches to the 15 amp hour battery. And that's been really great to have. That also allows, I have a solar panel. You can plug in a solar panel and keep it powered and running. So, yeah. No, the camper setup's simpler, but similar. Yeah, I actually use that battery. I just unplug it. All right, next slide, please, Carol. This is my entry panel. This is, I'm going to move over here for a second. This is one of the biggest challenges I've had as a relatively new ham, is how to get the cables into the house without damaging the house too much, right? So this is what it looks like before you paint it and put on bulkhead connectors. Originally, I just ran the cables right through without the connectors, but I wanted a better seal. I'm probably losing a little bit of power, but not too much. And that's a 6-gauge wire going from the ground rod in to the shack. All right, next slide, please. It's a sliding window. That should be a video, Carol. Yeah. No, the next one. Yeah, yeah. Oh, well, then we're not going to be able to show it. I have a video of the desk in action going up and back down. And that was going to be the highlight. Oh, well. Well, you can imagine it. It had sound up, down, but it's really great. So I stand probably 70% of the time. And I use it not just obviously for ham stuff, but paying bills and ordering on Amazon and everything else. So it's Carol, can you go back to the desk a couple. Yeah. This is the desk, the brand is called Uplift. And during COVID, I think it was their heyday when they made some money, but they also make a very high quality desk, and you can pick the size and the wood, and you can get bamboo and mahogany. You can do whatever you want. Yeah. And so, and you probably find them on Craigslist, but it's a very good, very smooth and quiet mechanism. It's fast. You push buttons. So there's a control panel here with 4 presets and some arrows. So you can adjust it. You can preset four heights, and you can also just adjust it incrementally by 1/10 of an inch. And it has a display showing you how many inches it is and the height. Maybe what I'll try to do is get my computer out, and we can, afterwards I can show the video. But yeah, so it's just a matter, you know, so the trick was really getting it set up so it would work efficiently and compactly. I also have front speakers, both for the FTM 400 and the 991, in different microphones depending on what I'm doing, and it's all on there, and I like it. So, yeah. Well, so on the right side is the Apple computer, and on the left side is the Windows computer. And what I've learned in this hobby is that you need Windows to really do anything. So that's Ham Radio Deluxe up on the screen, but I also do WinLink and Slow Scan TV, and all with the computer on the right. And the one on the left is the real computer. Exactly, Bob. It's the real computer. And then they can both share that it's the big monitor. They're both wired into that. It has 2 inputs. Yeah. And 2 cameras on top. Actually, if you go to another shot, Carol, maybe back one of the other ones. Go back. You can see I have two cameras for each computer, one on each side, so I could have a lot going on simultaneously. That was very helpful. That's been helpful when I was doing both work and teaching virtually, a lot going on. So, yeah. Neil. I need more wires. Yeah, I know. Well, you know, Phil, you got to give me credit. I have these power pole. I cut that myself, and I crimped them myself. Thank you. Any other questions? I'll get the video up on my computer. Yeah, Bill. Well, you can't, maybe go back one more slide, Carol. One more. There, whoops, come forward, just one, please. Right here, I have a bar, a bus bar for the 6-gauge wires coming in, and then the equipment's all attached to that. Yeah. Frankly, I don't know how much a difference it makes, because it was pretty quiet before, but it certainly makes me feel better. I read the grounding and bonding book, so I know I had to do it. Good question. Any other questions? Thank you all for your time.
Has anybody got a cleaner shack than his? I don't think it's possible. Mr. Wilson Head, you're up.
Carl, if you could control the slides, I would appreciate it. KP4MD has slide control. And my name again is Wilson Head. I'm November 6 Echo Mike Foxtrot. Good evening, everybody. And I want to present a homebrew project that I did, and I want to call it an XYL OM certifiable 2-meter dipole antenna. That's right. That's right. Two certifiable. We'll figure that out. 2 dB is not worth the divorce, they say, right? All right, next. Thank you. All right, so the reason for creating an XYL OM certifiable 2-meter dipole antenna. So I've heard a lot about people, guys, hams that can't install antennas at their home because of antenna restrictions in their neighborhood, or their wives or their partners or whatever would not allow them to install anything. And I always make this suggestion that maybe you could hide the antenna in a vase or behind some artwork or picture frame or something like that. So here's where imagine that you're a ham and you are wanting to install a 2-meter VHF radio antenna inside your living room. Have you ever wondered how you can install that antenna without running afoul with your housemates, your significant other, or visitors? Yeah. Next. I made it up. Well, there's a key to getting your antenna approved by your housemates, your old lady, or your old man. N6EMF has made that key, and he is going to show you how to build it. Next. So the key is an XYL OM certifiable 2-meter dipole. Next. I'm going to try to go over my goals for this project. Basically is to provide a solution to the age-old problem of antenna restrictions, particularly inside the home, where an XYL or OMAN or the certifiable antenna is the solution. The next goal was to design and construct a 2-meter antenna that would be concealed behind artwork, such as a picture frame or a poster. The number 3 was the rapid production and intentional imperfection, prioritized with speed of creation, delivering a proof of concept over neatness or completeness. So the idea here is not to be perfect, not to be neat or complete, but just to prove a concept that you can conceal an antenna. So the antenna must exhibit via SWR measurement of less than 2.0. And the idea is to use scrap or on-hand materials with no out-of-pocket costs. Next. Yeah, it will. Next up. So this artwork here serves as a means of concealment. This artwork was one of my son's second grade projects that had been photographed for keepsake, and then it was sent to the family disposal pile. So this was done about 10 years ago, and we still have this laying around for disposal. So I recovered this free raw material for this entry, and this artifact was created in about 2008. My desired antenna will be vertically polarized and fit this form factor. Next. So here's a slide that talks about the antenna element dimensions. To determine the total length in feet of both elements of a half-wave dipole, which is a half-wave length of the desired operating frequency divided by 468. I'm sorry, I'm a little confused here. You divide 468 by the frequency in megahertz. and that is L equals 468 divided by F. So I chose the input frequency of our RCARCS 2-meter repeater, which would be the mobile radio's transmit frequency, 144.65 megahertz. And so the length would have been this set of expressions here, and it all boils down to 38.8 inches. That's going to be the length of my half-wave dipole. Next. Thank you. And so the antenna element wire preparation went like this. The back side of this poster here was 20 inches tall and 15 inches wide, and the perimeter was about 70 inches. And I knew that the minimum wire length was going to be 38.8 inches. I needed something a little bit longer, and so my wife used to take this one extension cord that I gave her to use to charge her cell phone battery, and she would wind it around something all the time, and then it ended up kind of breaking down over time, and it was all twisted and mangled up. So I took that from her and gave her a refreshed one, but I took that extension cord and I cut it up and I saved it because I knew I wanted to build an antenna like this one day. So this is just a scrap extension cord where I took the wire and used it for the antenna, repurposed the wire for the antenna elements. Next. What was the buzzword? Repurposed, yes. All right, so preparing wire. I took some measurements. I unzipped the cord on the extension cord. I cut the elements to length, and you can see me marking up the backside of this poster with some ideas around, you know, what my perimeter was going to be and stuff like that. So I kind of outlined the perimeter of the backside and laid out the cord, and I used a pair of diagonal wire cutters to cut it based on that kind of approximate length. And you could see me starting to zip the cord open. And there's my kind of work area. This is my garage floor. Next. So again, with wire preparation, I'm stripping the feed point and testing the placement. So you could see me stripping the wire. And then kind of I had my son, Mason, he's the 16-year-old now that actually prepared this board when he was in 2nd grade. Those are his hands stretching the vertical portion of the elements along that backside. It is, yeah. So next up, thank you. And so here is, I think that's a duplicate photo, but the idea is we're working together, and I used some packaging tape, some clear packaging tape to just tape that vertically oriented portion of the element. You see a zip tie here where I zip tied that together to create a feed point. And then I kind of swung the elements around and taped them horizontally. The problem was that was the largest board I can find around the house, and I couldn't get it to be long enough to be fully vertical. So it sort of had to fold itself around the edges of the poster. So I left a little bit dangling, and I might be able to discuss why on the next up. Okay, so now wire preparation again. I'm working on the feed point. I put a, what do you call this thing here? This is a adapter for banana jack to BNC. This is called binding posts. Yeah, thank you, Carol. And so I kind of fed this with a little pigtail with an SMA connector. I taped in some strings so I could hang this as artwork somewhere down the road. And I was setting up for the test. So the next photograph here shows me, I'm sorry, the next photograph shows a coax. This is a 15-foot coax cable that I used to feed the antenna. And it was pretty much, I kind of skipped a step here. I cut this down to length as I was testing it on my antenna analyzer. So I can find a photograph of that. And since I forgot to put one in the slide, let me see if this works. So what you can see is it's kind of difficult to show, but what I'm showing here, that's a Rig Expert AA 230, I think. The idea here is that at my chosen frequency, my SWR was 1.29. And what I did was I took my diagonals and I just snip, 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 snip until it kind of hit that SWR that I was approximately looking for. And it changed anyway when I started moving the whole picture around. But next slide, please. All right, so the finished antenna is concealed behind the artwork. And this artwork was really a project that my son had to report on his second grade entry, where you have to talk about what you did during the summertime on entering second grade. So a lot of this is just things that he did, you know, little kind of a patchwork of things that he did over the summer. Next slide. So all goals were achieved. I demonstrated a solution to the age-old problem of antenna concealment. So I was able to conceal a working antenna behind artwork. Is there a comment?
You know, I think you should get extra points. There is not a wife on the planet that would object to you hanging your son's artwork in the living room. End of verse, extra points. You cannot lose. Great job.
Nice work. All right. So, thank you. Well, I know it's getting late, but what I could say was, so here's the certificate to you all. If you ever have the authorities come up to you, you can tell them that you've been trained in this method. So anyway, there's your certificate, and anyone in the club can use it. But I put it on the air last night and talked to James, AE6JG, and Jen, KI1TTY, and it was kind of a struggle because that binding post connector that I had connected to the feed point of the antenna, I'm sort of rushing. I didn't have it connected very well, so it was a little erratic, but it did work. But it didn't work inside my house on the wall because there's too much metal around the house, too many obstructions. But if I were to take it outside and put it up in the air, it works just fine. So if you're at a high elevation with no obstructions, it'll work fine. That's right. That's right. Thank you.
I'm gonna tell you, your wife's been snookered.
That you? Okay.
Hello. This is made out of old parts that are hanging around my messy desktop. You'll be very proud of me. And what it is, it's a buzzer. So when you're riding a bike, people will get out of your way and they'll hear it. I had a problem with my bell. It wasn't being heard. And so I went online. I bought a special, buzzer with like 3 different tunes, still not loud enough, still not loud enough. Now I had left over black boxes, switches, 9-volt battery jacks, and these 2 guys, which are, they're just little buzzers, which I use for my Morse code oscillator. So what I did was I said, I wonder if I could put something together, and I did. I got a step bit and drilled 2 holes, about 1 1/8 inch diameter, another hole about 1/4 of an inch, and then put my 9-volt battery in, and people can hear that, and it travels, and it's not too annoying or anything. And so, if you have some stuff laying around and you have a project or a problem to solve, this is a good way to do it. I couldn't find anything in the bike stores, and I ride quite a bit. I ride about, roughly about 60 miles a week altogether. And so it's really handy on the bike trips. Anyway, thought I'd share that.
We're going to watch the video of the desk in operation.
quickly. This is no, grab your mic. This is going to be very quickly, very simple, no presentations. I'll start by asking how many software engineers it takes to change a light bulb. And the answer is none because it's a hardware problem. I say that because I used to be a software engineer. So what I'm going to show you is me trying to do something in the hardware world. So it's perfect. Something nobody here has ever done before. I call it a power box with a battery inside so that we can use when you don't have it. You probably can imagine what that looks like. And this is the result of my first test. This is what it looked like after I made a whole bunch of mistakes. So I called it a prototype. Okay. And I think Bob saw this process in the work. The real end result I can get it out of the box is this. Okay. I do not go camping, so I don't need anything light. Just if we go to field day and something along those lines, it has a 38 amp hour bioenno battery in here. And what it does have, I don't know, I'll leave it here for the details. It does have the controller up front, the switches and the inputs and the outputs. It has external lights, which external lights. There are internal lights. There is a 12-volt output here through the normal Anderson power pole. In here we have a USB charger, and we have the banana plug just in case of need. Up front here, we have the input from the solar panel with its own F1 switch. So that I did put two 100-watt panels up on the roof in front of the house, on top of the garage. And so this is connected all the time. It's just like you mentioned, I try to run on battery most of the time. Inside, like most everybody, we carry the extra wires, the chargers, and it has they're all fused. So very, very simple, not much different from what you guys have done before. And but since it was one of my first hardware projects, I wanted to come in and show up. Okay.
Very nice.
as a
Don't
s-
drop it on your foot.
As a side detail, front here you have the logo and all 12. And by the way, if you come and take a look, all of these buttons, they have labels, and I had it made by Auburn Trophies. And I don't know if anybody works with them, but they turned out to be incredible people. They made those things for just a couple of dollars. And along with the power box, the other thing that I did was what I call a 12-volt distribution, source distribution. And it's a switch that you can turn from the power supply or the battery. The only problem that I don't have what you have, what I was looking for, what's called an MBV switch, like make before break. And what I have is the break before make. So, which is, if somebody remember those rotary switches that we used to have, you know, make the contact before you break the contact, or break before, different purposes. So I'm going to have to change that. But anyway, that's it. Because of the shortness of time, anybody has any question or would like to see the secret circuitry inside, I will. Thank you.
Neil, thank you. I have two questions.
Yes, sir.
James, what year were you first licensed? 2021. Oh, do you? Great. And then Bill, when were you first licensed? 2022. Okay. Thank you. All right. I guess there's going to be some displays over there. We're going to get the scores tabulated. And now the one thing, and you guys, I want you to applaud. Jojo came here. I think he brought the money. Because if he didn't bring the money, I was doomed. Thank you.
Art's not on this. Okay. Yeah, I'm no good at this. This is what I got for art.
Yeah, no, everything, I don't think everything needs. And, well, in case 75. So Carol, I think the whole thing, if you hit the lottery and you live in a restricted area, it is extremely big. But my wife,
It's just a beeper, right? When he's running. I don't know what he's calling it. It's a beeper sometime, yeah, warn people he's on a bike trail. We are displaying. They actually have a flag displayed on the thing. But they won't let up the flag. Very nice. You know.
Are we live? All right, we got some money. And what I need is James. And I need Jojo. Because Jojo's going to give you some money. Yep. Second place goes to James.
Thank you, judges. Congratulations. Thank you. $20.
Okay. All right. The newbie prize goes to Bill. That's $40. We're going to make a nerd out of you yet. And then Wilson, stand up, buddy. You're the grand winner. Yeah, he's got all the money. Okay, so next month, bring your stuff that you'd like to donate to the club for revenue generating purposes. And we have to knock this out in about 2.5, 3 hours next month. So bring stuff in that you think is going to sell, because whatever we don't sell, we got to take back out with us. And again, this nomination thing is still open. If there's anybody you think that belongs in one of our officer capacities or board members, write a note to contact@n6na.org and put your name in there. And then in November, as I said, we'll do the formal election. And again, in December, we're going to have our holiday extravaganza. And in the October newsletter, and from that point forward on our website, we will advertise what the meal choices are and what you need to do to get them prepaid. I think we'll probably use PayPal for that again if we still can. I think we can still do that. Make it easy. But that's it, unless anybody's got any questions. We need a little help stacking up the chairs and taking things down, and great efforts on everybody's part. I'm really duly impressed. Thank you all.
All done well.
successful.